Hello, everyone. Welcome to our first lecture, which is Introduction to Physical Chemistry. Now, when we say physical chemistry, so physical chemistry is the systematic application of the method of physics to study chemical systems. So, physical chemistry is the branch of chemistry that establishes and develops the principles of the subject in terms of the underlying concepts of physics and the language of mathematics. It provides the basis for developing new spectroscopic techniques and their interpretation for you to understand the structure of molecules, details of their electron distributions, and for relating the bulk properties of matter to their constituent atoms. So physical chemistry involves in the development of principles, theories that explain and interpret the behavior of chemical system. So physical chemistry also provides a window to the world of chemical reactions and allow us to understand in detail how they take place. So from microscopic chemical system, which is the based on concept of molecules, to macroscopic, wherein large scale properties of matter without the use of molecule concepts. Now, just to give you an idea more on physical chemistry, this could be divided into thermodynamics, statistical mechanics, quantum chemistry, and kinetics. So you will realize that later on, PChem is also related with your thermodynamics course if you are taking it this term. Also, in your future course, which is chemical reaction kinetics. So thermodynamics is a science of energy, how energy transforms, involve heat and work, and the changes they produce in the states of the system. So for statistical mechanics, this is on the molecular insight to the laws of thermodynamics. So you will understand the laws of thermodynamics on a molecular level. And this allows calculations of macroscopic thermodynamic properties from molecular properties. So quantum, if you'll be taking physical chemistry on a higher level, so this refers to the properties of molecules and their applications. Applications, molecular bonding, atomic structure, and spectroscopy. So later on in kinetics, so which involves the study of the rate processes such as chemical reactions, diffusion, and flow of charge in an electrochemical cell. To give you an idea on thermodynamics, when we say a thermodynamic system, so this consists of system. So what is a system? So this is the part of the universe in which we have special interest, quantity of matter or region in space chosen for study. So what about surroundings? Surroundings is mass or region outside the system. And a boundary is a surface that separates system from the surroundings. Now, when we say thermodynamic boundary, obviously this is a separation between system and surroundings. But you know that we have certain types of thermodynamic boundaries. One is rigid or non-rigid. Next is it could be permeable, which allows matter to pass through. In adiabatic, so it could be thermal conducting or non-adiabatic, which is non-thermal conducting. Now, types of thermodynamic system. So we have what we call open system, closed system, and an isolated system. Now, take note that for open system, there's an exchange both of mass and energy that is flowing across their boundary. For closed system does not have mass flow across the boundary. It involves only changes in the energy. And for isolated system, there's no interaction between system and surroundings. So it means matter nor energy can be transferred. Neither matter or nor energy can be transferred between the system and surroundings. Now, for thermodynamic equilibrium, so when we say thermodynamic equilibrium, there's no change on the macroscopic properties. It remains constant with time. And for thermodynamic equilibrium, all three types of equilibrium must be present. And what are those three types? It could be thermal, mechanical, and chemical. So obviously for thermal, there's no change in properties of the system or surroundings when they are separated by a thermally conducting wall. So one of the parameters that is involved here is temperature. So when we say temperature, so this is this refers to the hotness or coldness of a body. And sometimes temperature is defined as property that determines the direction of heat flow. Describes the properties. This is a property that describes the flow of energy. So energy will flow between two subjects in contact, which results in change of state of these two objects. So if objects A and B are touching and A has higher temperature than B, so energy flows from A to B until equilibrium is achieved or established. So figure A here, there is a diathermic wall. So if a change of state is observed when two objects are brought into contact with one another. And then adiabatic, there's no energy flow that is permitted between two objects in contact. So if this figure shows that from high temperature to lower temperature, matter flows. And then when equilibrium is achieved, so temperature is equal in both systems on the left and right. That is separated by a diathermic wall. So thermal equilibrium are said to be achieved if no change in state occurs when they are in contact with one another. And zeroth law of thermodynamics, so if you have this system and A is in thermal equilibrium with B, B is in thermal equilibrium with C, therefore C is also in thermal equilibrium with A. And you know that to convert the temperature scale into Kelvin, so if you have the temperature in degrees Celsius, plus 273.15. Now, mechanical equilibrium is related to pressure. So mechanical equilibrium is achieved when there's no change in pressure at any point of the system in time. And whenever there's a net force on an object is zero, or when it becomes zero, the object is in mechanical equilibrium. Now, pressure is another important parameter. So gases can be stored in two separate containers. So separated by a movable wall. So let's say I have a piston. So the higher pressure gas will move the wall. So high pressure will move the wall. Compress the lower pressure gas here, like what you have seen in figures letter C, until an equilibrium pressure is established. So the piston is said to be in mechanical equilibrium at this point. So pressure is the force exerted by the gas on a unit of the container. So we define pressure as force per unit area, and high pressure indicates that there's a great force that is acting on a given surface. Pressure of the gas in a mechanical system involves a piston and can be controlled by a gas entry and release valves. So these are set or controlled to let gases in and out at a certain pressure threshold. Now, so we're done with thermal equilibrium, now in mechanical equilibrium. So last is chemical equilibrium. So in chemical equilibrium, there's no net chemical reactions that occur in the system. No net transfer of matter from one part of the system to the other, and the concentration of chemical species in the various parts of the system are constant with time. Now, we also need to review types of thermodynamic properties. So what are extensive properties or extensive variables? So extensive depend on the size of the system. So we have mass, we have volume, while intensive properties or intensive variables, they are independent of the amount of mass of the system. So what are examples of intensive variable? Pressure, temperature, specific volume, and density. Though density is mass per unit volume, so take note that density of matter depends on what type of matter is. So density of water is different from density of solids and density of gas. Now, we also need to review temperature and pressure scales. So when you say ice point, so this is the temperature equilibrium between pure ice and liquid, water with air, saturated with vapor at 1 atmosphere and 0 degrees. And steam point is a temperature equilibrium between pure liquid water and water vapor at, so what's the temperature? 100 degrees Celsius and 1 atmosphere. So take note, you need to also to review conversion of temperature scales. So Kelvin is Celsius plus 273.15. So Fahrenheit is 1.8 or 9.5 times the temperature in degrees Celsius plus 32. So I mentioned this earlier. So pressure refers to the force per unit area, amount of equal force measured in Newton to a specific area, measured in square meters. So these are the different units of pressure: Pascal, bar, atmosphere, torr, millimeter mercury, and pound per square inch, or PSI. Take note of the conversion from one unit to another. So one device used to measure pressure is barometer. And then a simple pressure measuring device is a manometer, in which non-volatile viscous fluid is contained in a U-tube. And the pressure is measured directly proportional to the height difference between the two columns, rho GH. Rho means the density of a viscous fluid. G refers to the gravitational acceleration, 9.8 meter per second squared. And H refers to the height. So in problem number 1, given the density of mercury at 0 degrees Celsius is 13.6 gram per cubic centimeter, and that acceleration due to gravity is 9.8 meter per second squared. So calculate the pressure in Pascal of a mercury column 760 millimeter high. So to solve this, so pressure is equal to rho GH. Rho, density is 13.6 gram per cubic centimeter, so converted to kilogram, converted to cubic meter, multiplied by 9.8, multiplied by height in meter, 0.76. So the answer is 1.013 times 10 raised to 5 Pascal, or 101.3 kilopascal.